Experimental research designs. This is still part of the longer discussion about research, but I encourage you to consider looking at the book How to Design and Evaluate Research in Education by Franken and Wallen. But nevertheless, we can go back to the more primary texts as we will see in these slides. If you haven't subscribed or liked or shared this video in your social media, please do so and help me gather subscribers and views. The general roadmap for research is very interesting, especially with the advancement of other research methodologies that are qualitative as well as one that incorporates the mixed method. Nevertheless, there are different ways of doing research, and there's no singular way. We need to take into consideration that depending on our understanding of the world, our research also changes. But there are things that we need to take into consideration, and they will fall into the major components of the research design. These would include, of course, those who would be involved, how the data will be gathered, and the like. Designing the research must also ferret out causal relationships, and we will see that as we try to look more deeply into the possibilities and enhancements that are embedded in experimental research. And then we'll try to look at again the difference between social science and the natural science. When we look at research in general, there are actually two very broad perspectives there. One is the theoretical, the other one is the empirical. When we look at theoretical research, we're more interested into identifying the philosophical presuppositions, the assumptions in understanding reality, which can, of course, be understood in terms of knowing what is normative or what is acceptable or what is positive. These can be contrasted also in relation to the causal, the cause and effect, which is the causal comparative model for doing research, the correlational, which is the more relationship, the interest with relationship, as well as the survey, which is the more descriptive. So here we will see the relationship, the direction or the possible direction of a research. Now, there are different ways of doing empirical research, and experimental research is one of the way. When we do empirical research, we need to take into consideration one, the interpretative dimension, how we interpret, analyze, or even treat data. Two, the small population case study, which can actually recourse to a single subject experimental research or single subject research, which is equivalent to the case study model in qualitative research, as well as the large population statistical analysis that involves really getting the representative size as well as processing data. The interactions among these ways of doing empirical research will play a very important role in the success of research design, especially in the quantitative dimension, where numbers play a very huge role. The determination of the sample size, for example, in contrast to the total population, as well as the use of appropriate statistical tools must be taken into consideration. Now, when really considering research designs, we need to look at the research questions. Well, sometimes research questions don't often tell us that it is automatically quantitative. They can be indicative. That's why in the prevalence of mixed methods right now and of social science pushing its claims forward, we need to also see how certain questions which sounded like quantitative research questions are in fact answerable qualitatively. We need to take into consideration also the play of theory, the theoretical assumptions, which will play a very important role in the choice and in the determination of um, the research design to be implemented. The second one, of course, is what type of data we will be dealing with. Are we going to deal with numerical data? Or are we going to not deal with qualitative data? These two are very important in the identification of what data we will deal with. Now, the research question must also be taken into consideration. It's important that the research question is not too broad and not too general, and that it's also important that it's not very specific, very small, but that it should be the just right. Of course, the identification of the research questions, again, will have to do with the appropriate theoretical support that we are able to provide directly or indirectly to the questions that we ask. It's also important that by speaking of literature, we need to ask whether we are in fact pushing forward learning in the exploration of these research questions. So we need to search in and or at good journals. And when we say good journals, we need to consider whether these journals are indexed or in fact even peer-reviewed or refereed. In terms of theory, we need to look at the general statement of a proposition, and that argues why events occur as they do or predict future outcomes as a function of prior conditions. Here, in terms of theory, we need to be able to see the general perspective or the concrete trade-offs in the identification or even the determination of these theories. Here we can also look at the falsification theory of Karl Popper, as well as the parsimony understanding of William Occam or Occam's razor, that we do not repeat things unnecessarily, or that we simply identify what we need to falsify. Now, in terms of data, of course, when we start talking about data, we need to look at the terms, the cases, the observations, or in the variables. What are the variables in the study? And by variables, of course, we refer to really four types of variables: dependent and independent as a primary relationship. But we also need to take into consideration moderating and intervening variables. By units of analysis, we not only need to consider whether the data is categorical or not, or qualitative, we also need to look at it in terms of the measures of central tendency, in terms of nominal, ordinal, interval, or ratio. And in terms of measures of central tendencies, mean, median, and mode. So we need to be able to consider whether the data we are going to deal with are in fact calculable or better described. By doing this, we are able to map between the abstract and the concrete, which we will see as we move forward. In qualitative research, in order for data to be manageable, the reduction of these data to numbers will play a very important role. By the way, these slides came from MIT, and copyright belongs to whoever it's due. And it's also important to look at measures as well as indicators. What are the measures and what are the indicators that are in place? Now, causality. When we look at research, we need to take into consideration cause and effect, causality. And when we look at causality, we need to pay attention at how we understand causality and whether we can in fact ascertain that the consequences that we are seeing is in fact a result of the causes of the cause, that the effect is in fact a consequence of the cause. Now, of course, the definitions of causality can be logical as well as experiential. When we look at logical, that's an technically A causes B if the presence of A constitutes a sufficient condition for B to exist. That is like modus ponens in symbolic logic, where we can say if A, then B, where A becomes a condition for B is the antecedent for B. When we look at, of course, experiential, we're looking at A causes B. If B occurs following the exogenous introduction of A. So the addition of the word exogenous makes it a little bit interesting. So when does exogeneity occur? So when ethnic names on resumes, for example, exogeneity, or campaign spending towards winning, that's also exogeneity. It's very difficult to argue what the direction is, except in terms of these two. Now, the biggest problem, of course, in causal research is to establish the exogeneity of causes, as I was saying a while ago. And that's the reason why it's not always easy. So Donald Campbell and Julian Stanley in the book Experimental and Quasi-Experimental Designs for Research 1963 established what is to be a very good help or guide in exogenous in establishing causality. They speak of 6 design types: the one-shot case study, the one-group pre-test post-test design, the static group comparison, the pre-test post-test with control group design, the Solomon 4-group experimental research design, and that's the really ideal experimental research, if they often say, and the post-test only experiment design. Let's look at these 6 one by one. So the one-shot case study is basically, literally, one shot. For example, if X, then O, or if O, then X. That's a one-shot case study because this caused that. It's just like that. So here you see these more often in instances of journalism where reporters report that this caused X, something like that. It also happens in instances of common sense. While it's true that it's not always common, but nevertheless we call it common sense. But these, we need to warn people, is often of no scientific value. It has no scientific value because it's a particular instance of cause and effect. And particular instance does not always imply repeatability. It does not always imply that X was really the cause of O or O was really the cause of X. So we go to the one group pre-test, post-test design. So it follows the beginning until the end, where it's worth emphasizing that in this beginning, O here is the pre-test, and then the X here constitutes the intervention that was made, and then the other secondary O is the post-test. Of course, at the end of the day, we compare the pre-test and the post-test, thinking and arguing that any change in the scores, for example, between the first O and the second O was a consequence of the intervention that was inserted. Of course, because this is a one group design, it is worth emphasizing that there's no basis for comparison except the same group, pretest and posttest. This is better than nothing technically, but most of the time this is a standard way of doing research. But the problem with the one group pretest posttest design is that there is no comparison group. That means there's no controlled group, there's no experimental group, or there's no group by which we can compare the two. Second, that there are no random selection, random assignments, and that most of the time we only work with what we already have. And for that matter, we are operating with samples of convenience, if you will. No? And for that matter, something that we need to take into consideration because randomness is also very important in quantitative research. The static group comparison is different from the one group test because instead of having one group alone, there are two groups. In this case, the intervention X is conducted, whereas on the other side, there's no X. But at the end of the day, again, they will be post-tested, sorry. And that comparison between O1 and O2 will be made, assuming and presuming, of course, that any difference between O1 and O2 is a consequence of the intervention, that was made, that is of X. So that while it's true that we still compare O1 and O2 here, the inclusion of the X is important. So this is the most cross-sectional and correlational analysis because there's a comparison here. Nevertheless, the problem here is how the two groups are selected, and better yet, there is no pre-grounding, and for that matter, we are not sure whether the intervention was a consequence of the treatment X or any other variable. Let's look at the pre-test, post-test control group design. In this instance, there are still two groups, R1 and R2. Let's just call them that. And then they will be pre-tested, both. The intervention will be conducted in the first group, as can be seen in this model as X. And then the two groups will be post-tested again, assuming again that any difference between O1 and O2 in the first group as well as the second group is a consequence of the intervention. But what is great in this combination is that you can also compare O2T and O2C, arguing further that if there is a difference between X and the first group and the second group, is in fact a difference brought about by the introduction of intervention X in one of the group. So in this case, you would see the effect of treatment will be to see the difference between O1 and O2, but also to not just to check the differences across groups, but also to look at the differences between groups. And in that case, we subtract O2 to O1 and subtract O2C to O2C. No? This is, of course, the classic randomized experiment test, but there is the problem of the Hawthorne effect. And that's also something that we need to pay attention to, the Hawthorne effect. I'll leave that to you to research. The Hawthorne effect has something to do with students seeming to get higher scores in a post-test after a pre-test and something like that. So something to consider. The one of the strongest research models, as I've also said, is the Solomon four-group design. Technically, this is a combination of the first groups that we looked at. See, in this case, the pretest post-test design. This is also the post-test design, no? So again, the inclusion of the intervention in R2 and R3. But here, the pre-testing in R1 and R2, as well as the post-testing in R1 and R2, the intervention in R3, and then the post testing between R3 and R4. So here in this case, you would see that two of the earlier models that we spoke about were put together. And in research, especially in experimental research, the Solomon four-group research design or experimental design is one of the strongest research designs, precisely because of the prevalence of data. It's very difficult to put into question the differences and whether the treatment that was done do in fact affect the group. This allows you to control for the effect of the experiment itself, and therefore something to consider. The post-test only experiment looked like the first one of the first that we looked at here, the static group comparison. The problem here is the absence of a prior observation. It assumes, of course, that the first group and the second group are the same, no? And therefore that the difference in the results is a consequence of X. And we sometimes see this one in classical, scientific, and agricultural experimentalism. So that's your experimental research. So where do standard research fall among the Campbell designs? In the one-shot case study, that's of little scientific value, but may be descriptively helpful or useful. The one-group pretest post-test study is often used in policy analysis, but only justified as a best design if there are ethical or other constraints that are taken into consideration. The static group comparison is correlational, no? By far the most common scientific social research that is conducted. In the pre-test, post-test with control group, there's the real experiments, but growing in frequency also. No, of course, quasi-experiments are growing more rapidly than real experiments, and quasi-experiments are like experiments, but not as rigorous as they should be. The Solomon four-group design, actually, in all honesty, that's supposedly the best, but I would admit that I haven't recalled ever seeing that, not once. And then the post-test leads to weaker statistical tests, and therefore the suggestion of other tests as well. We need to pay attention, of course, that there is a very huge difference between social science versus natural science and engineering research. Here we see in social science, in the natural science and engineering, there's a high degree of reductionism, reducing everything to numbers. And therefore, the implications of measures of association with the weak, and therefore aggregates of often better predictors. Sometimes it often puts into question also why we even have to use statistics. Of course, there's also a pre-recording on the causal comparative model, and please stay tuned for it. Thank you very much for paying attention. Please, again, support the channel, Samo't Simula, by liking, sharing, and posting it. Thank you very much.